Alright people, welcome back. So in today's episode, we're dealing with problem 221, Maximal Square. So given an m by n binary matrix, so it's not necessarily a square, filled with zeros and ones, find the largest square containing only ones and return its area. I really believe I already saw this problem. Maybe it was probably in a Google interview that is currently available in YouTube. I remember that that was a mock interview, and I think the fake interviewer was solving this algorithm. However, the point is I don't remember how it was solved, so good. So basically we have a matrix and we have to find the maximal square. But specifically we should return its area. So in this case we should return 4. Okay. Okay, and the maximal square is the two squares with maximal area are the red one and the green one. So the output here is 4, here is 1, here is 0. Okay, good. So my idea, let's use a dynamic programming approach, of course. So let's say that we create a grid, this is the first grid, the matrix, but let's say for example that we create something dp, and then we say something like dp okay, in each let's say position of the dp, we put the area of the greatest square that has as top left corner the cell we are currently taking into consideration. So for example, let's say that we are here, so dp, and this is going to be dp 2 1. Okay, so dp to 1 must be equal to 1, because basically the area, the square you can create with this cell at the top left corner is just it has a maximum area of 1, because then if you try to extend these three numbers, they should be 1 and they're not. I don't know if this approach works though, guys, because I don't know how to create this dp iteratively. So let's see if there is an hint, and unfortunately there's no hint. That's terrible. That's really terrible. All right people, I'm back. Actually you will see an editing here because I had to leave, and I am now back again. So here we're still solving the same problem. It's just me a day passed. So in the meantime I had a bit of time to think about how to solve this problem. And I actually believe we were on the right track. The only problem, I think it's possible to solve the problem with the approach we outlined previously, but I believe it's better if we do that the other way around. So basically, instead of asking ourselves, for example, given the cell 0, 0, so this one here, is this part of which square of ones? A square of length 1, 2, 3. Okay, instead of saying that, instead of asking if this cell is the top left corner of any square, we may ask instead if this cell is the bottom right corner of a square. Okay, so it's like we are going this direction instead of going this direction. Okay, it's basically the same. It's just a matter of interpretation. And why I think this is better? Because then we can use a dynamic programming approach by simply initializing this first row and this first column, okay? Because of course we know that if you are in the first row, you can't, if you are the bottom right square, a cell of a square, you must, the square must be of length 1. So this is the square of unit of length 1. This is the square of length 1. These are 0. And it's the same for here, right? Okay. And now once we have initialized the first row and the first column, yes, you can just update the rest of the grid by simply saying that basically the number, the length of the square in this cell, given that this cell is a 1, so of course this will not be the case, but here is basically equal to the 1 plus the minimum between the three cells, the one above, the one at the left, and one at above and at the left. Okay, so in this case it will be 1, but here it will be 1 plus the minimum of this, and this is 1, this is 1, and this is 1, so this is gonna be 2. Okay, And then once we have the grid, we simply take the maximum of the grid. So this is my idea. Now let's see how we can code it, okay? So my idea is to define maybe another grid, okay? And let's say that, so first of all, like this grid will be something like 0 times, okay, so first we need to define n as the length. Actually, yes, m must be the length of the matrix, while n is the length of the matrix, like of the row of the matrix, okay? Now, given n and m, I can just do something like I update dp as 0 times n for I in range m, something like that. And now we have our dp. Now I basically just do something like I want to initialize the first row. So let's say dp0. I want it to be equal. Actually, let me do so for I in range n, dp0 I is equal to 1 if this is equal to 1. Sorry, I want the matrix. So if the matrix is equal to 1, then I want dp0 I to be equal to 1. Maybe what I can do is to simply say dp0 I. No. This is completely not necessary. I can just update, like I just create dp as basically the copy of the grid. Well, actually, to be honest, I don't even need to create a dp because I can just use the matrix directly. Like I can do for I in range 1 m, then for j in range 1n, I can do something like matrix I j. This must be equal to the minimum. This must be equal to 1 plus the minimum between matrix I minus 1 j, matrix I and j minus 1, and matrix I minus 1 j minus 1. And it should be there. Yes, and then what I can do is to simply return the maximum of the matrix, something like that. Let's see what happens. There is an error. What's the problem here? Unsupported operand type 4 plus. Because this is a string. You see here? It's a string. Okay, that's fair. You want this to be an int? I'll give you an int. No problem. That's what you want. I'll give this to you. I see. You want everything to be an int. Well, what I can do is to simply say if matrix ij is greater than the maximum, then update the maximum as matrix ij. Okay, and then I can just return the maximum, something like that. And of course, the way I initialize this maximum is something like minus inf. Actually, I think I should have created this way, maybe. The output is 3 here, but the expected is 4. The output is null here, the expected is 4, and here is 1. So let me see what's the problem in here. So for sure, like if n or m are equal to 1, this is skipped completely. Actually, no, it's not skipped. It's just, it is skipped. Yes, it is. And this is the problem in case 3. Like with 0, you can't return anything, right? So the point is you must return either 0 or 1. So let me see. I must add an if statement in here. So like if n is equal to 1 or m is equal to 1, then what? Then I want to return, let's say for a moment that I return 0, but this is of course not good enough because for this specific case it works. But here there is a problem. Let me see. The expected is 4. I don't understand why it is 4 though. So here it would be like we need a square of length 4. What do we need to return? Largest square containing a return its area. Come on, bro. Okay. So this was completely wrong. Okay, I'm so sorry. Okay, so you want this. Okay, but this is still incorrect because I am literally doing less than what I'm literally returning a square of length of length 3, even though it should be a length 2. Okay, I believe the problem here is that we are not, like, we are also adding 1 to the zeros, but this makes no sense because you cannot create a square of length 1 if your cell is 0. So basically what we have to change is that if this one, matrix ij, is equal to 1, so what I can do is to say matrix, let's say a matrix ij is equal to int this. So I'll make it an integer. And then if it is equal to 1, well, actually this is not necessary because I can check if it is equal to 1. Then I do this. Otherwise, I don't do anything. You see what I mean? So let's see. It doesn't work because it is not, and this must be under this if statement. So I check if this is greater than maximum, of course, if this is equal to 1. Otherwise, I don't do anything because it will be equal. So case 1 now is correct. Case 2 now it's null. Why? Because you look at, okay, the only number you look at is the 0, 1, so you skip everything and you return 9. Okay, better to do this then. For I in range m and for j in range n, if matrix ij is equal to 1, I do this. This is 1 plus the integer between, and this is what I do. Matrix, the minimum between 0 and I minus 1, j. Here I do the minimum between 0 and j minus 1, and here I do the minimum between 0 and I minus 1, and the minimum between 0 and j minus 1. And that's it. And let's see what happens now. Now it gets accepted. Wow, that's crazy. Let's submit it. But yes, you see, like for this specific scenario, we're still returning 0. But this is like we can, since now we are not starting at 1, but we're considering the whole range now, this should be solved. No, it doesn't, because the length is equal to 1 in both cases. Yes, but in this specific scenario, m is 1 and n is 1. So it should do something. Okay, I see what's the problem. So maximum must be initialized at 0, something like that. Here the output is 4. That makes definitely no sense. I see what is the problem here. So the problem is we are adding 1 to the number itself. So this makes no sense. So we can say something like if I is equal to, okay, we must do this way. If matrix ij is equal to 1, and I want I to be greater than 0, and I want j to be greater than 0. Then let's remove this minimum. That was a nice try, but I don't think it works. Here again, same stuff. Here again, same stuff. So here's what we have. This was the starting point. And then we are like, if maximum I is greater than that, this thing. So if the match, so suppose, look, the case is, if it is equal to 1, it is great, and it is greater, like an I is greater than 0 and j is greater than 0, then it gets updated. If it is not either equal to 1 or equal to, or I is greater than 0 and j is greater than 0, what I can do is to simply say that if it is equal to 1, so it is the case that it, like either I or j is equal to 0, then the maximum gets updated anyway, okay? So what I can do here is to write down int. Maybe at this point it's better to do matrix ij is equal to int matrix ij. So this will be equal to 1, and this can be done, and this can be done. Okay, so the new algorithm is the following. I think it should work. It doesn't. That's because there is a j here, but it shouldn't. Okay, first let's run the tests. The tests are accepted. Now let's submit it, and it does submit, which is fantastic, to be honest. Okay, guys, well done. So we approached it with the following. So first we define m and n, then we define a maximum, and so basically if m or n are basically 0, then of course we return the maximum 0 to the square, 2, so we return 0, okay? Now, if it is 1, then basically, like we use the whole range for the for loops, but we skip the updates if I or j are equal to 0, okay? But if they are equal to 0, either I or j, then we still update the maximum to 1 in case there is any 1 in the first row or the first column, okay? Then, of course, if we have more than one row or one column, Then we start updating with the approach I outlined at the beginning. So basically here, this is gonna be the maximum of these three, the minimum of these three. Here, with this cell, this is the bottom right of just a square of length 1. Here it's 1, here it's 2, but the minimum is 1. So this is gonna be 1 plus 1, which is 2, okay? So these are the only cells where the value is 2. So we return maximum to the square, which is 4. And for this example, we actually return 4, which is what we were expecting. So thank you very much, guys, for watching this video. I think it was a very nice problem to deal with. I had a lot of fun. So thank you very much and see you in the next episode.